This is SpaceTime Series 26, Episode 68. Coming up on SpaceTime, a 10,000-kilometre high water spout discovered on the Saturnian ice moon Enceladus. The search for habitable planets expands. And NASA's first public UFO meeting. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers have discovered the biggest water spouts in the solar system. 10,000-kilometre tall geysers shooting deep into space from the Saturnian ice moon Enceladus. The stunning observations by NASA's new James Webb Space Telescope represent the tallest water geysers ever seen. The plumes, reported in the journal Nature Astronomy, are shooting out of Enceladus' South Pole tiger stripes, where the tiny moon's icy crust is thought to be especially thin, thereby allowing the water in the global subsurface ocean below to erupt onto the surface. The tiny frozen world of Enceladus is just 505 kilometres wide. That means the plumes are 20 times larger than the moon itself. Sandwiched between its icy outer crust and its rocky inner core is a global reservoir of salty liquid water. It's kept liquid and prevented from freezing by the gravitational tidal effects as the little moon orbits around Saturn and other moons. These constantly crush and squeeze on Enceladus, and that causes friction, and that causes heat, keeping the water liquid. The cryovolcanoes are spewing jets of ice particles, water vapor, and organic chemicals out of the tiger stripe crevices and onto the moon's surface. Astronomers want to study these geysers in greater detail to better understand the chemical compounds in the water vapor. See, this will allow scientists to understand the global subsurface ocean and determine its potential habitability. It was during its 13-year reconnaissance of the Saturnian system that NASA's Cassini spacecraft discovered that Enceladus has a subsurface ocean of liquid water. And it was able to analyze samples as plumes of ice grains and water erupted into space from the cracks in the moon's tiger stripes. The study's lead author, Christopher Glynn from the Southwest Research Institute, says Enceladus is one of the most dynamic objects in the solar system, and it's a prime target in humanity's search for life beyond Earth. In the years since NASA's Cassini spacecraft first looked at Enceladus, scientists have never ceased to be amazed by what they see happening on this extraordinary world. And these latest observations, made thanks to Webb's new infrared spectrograph, have revealed some remarkable results. The instrument's sensitivity has revealed a news story about how Enceladus feeds its water supply to the entire Saturnian system, including Saturn's majestic rings. As Enceladus whips round the gas giant every 33 hours, the moon spews water, leaving a halo almost like a donut in its wake. The plume is not only huge, but the water spreads right across Saturn's dense E-ring. The new Webb data indicates that roughly 30% of the water stays in the moon's wake, while the other 70% escapes to supply the rest of the Saturnian system. Glenn says the ongoing research of Enceladus will look for specific indicators of habitability, such as organic signatures and hydrogen peroxide. Hydrogen peroxide is especially interesting because it can provide important sources of metabolic energy. Now, Cassini didn't give a clear answer on the availability of strong oxidants on Enceladus, but the new Webb observations will provide the best remote opportunity to search for habitability indicators on the moon's surface. And understanding the variability of plume outgassing is also important in order to plan for future planetary missions to Enceladus to study the water vapor plumes. So Webb is sort of serving like a bridge between Cassini and a proposed future mission to Enceladus dubbed Orbanlander. After the next set of Webb observations, astronomers will have a better idea if ocean samples are widely distributed across the Enceladian surface, as opposed to just near the South Pole tiger stripes. This report from NASA TV.
In February 2005, we had our first close flyby of Enceladus, and the magnetometer signal saw something unusual.
What a magnetometer does is it measures the magnetic field in the vicinity of the instrument. We had a look at the wiggles, and they looked strange. The magnetic field of Saturn is moving towards it, and it couldn't penetrate down onto the surface, which was pointing to an atmospheric signature of some kind.
Here it looked like it had a tiny atmosphere. In March, we came even closer, looking for that same strange signal.
What it showed was that the signature, the atmospheric signature we were seeing, was focused at the South Pole. It was almost like there was a cometary plume of water vapor coming off from the South Pole.
People were saying, it's got to be jets, it's got to be jets. And the imaging team was saying, no, we don't want to say that, until we're sure. And so we went closer. We came within 175 kilometers of Enceladus.
Then we got the data back, and it was spectacular.
And then we found the evidence. Geysers coming out of the South Pole with water vapor and water ice particles. They were active geysers at the South Pole of Enceladus.
Because we were so close, all of the other instruments were able to take really good data. And we put together all of this data. We saw the cracks, the tiger stripes at the South Pole. We saw heat leaking out from these tiger stripes. On subsequent flybys, we found organic material, dust, water vapor coming out of the plume.
The Cassini discoveries in the first 3 flybys were so amazing. We changed our focus and added 20 more flybys of Enceladus, including 7 through the icy jets. The surprising magnetometer reading led us to the liquid water ocean underneath Enceladus's icy crust. After over a decade of research with Cassini, we now know there's a potential for the ocean on Enceladus to support life. And that has altered the way we think about where life might be found in our own solar system and in the worlds beyond.
And in that report from NASA TV, we heard from NASA Cassini project scientist Linda Spleeker and NASA Cassini magnetometer principal investigator Michelle Doherty. This is SpaceTime. Still to come, the search for habitable planets beyond our solar system expands, and NASA conducts its first public UFO meeting. All that and more still to come on SpaceTime. Scientists are expanding the search for habitable worlds to areas beyond the so-called Goldilocks zone. The Goldilocks zone is the area around a star where temperatures are not too hot, not too cold, but just right for liquid water, essential for life as we know it, to exist on the planet's surface. Of course, all that assumes the planet has an atmosphere with enough pressure to prevent water sublimating directly from an ice into a gas, and also that the planet isn't being irradiated by stellar flares erupting from the host star. A new study reported in the astrophysical journal Letters suggests a new way to expand the search for habitable planets. The hypothesis also takes into account a zone not previously considered, the space between the star and what's known as the soot line in the planet-forming disk. See, worlds that form in this region, a disk of dust rotating around the central star, could have surfaces rich in volatile carbon compounds, quite different from the Earth. The study's lead author, Professor Ted Bergen, says these planets would also be rich in organic carbon, but poor in water. When scientists search for Earth-like planets, they're usually especially interested not only in the worlds that look like the Earth, but also those that look like they were formed through a similar process. Current models of rocky Earth-like exoplanets are built using Earth-like atmospheric conditions and bulky composition, including the molecules essential for life that form from carbon-based building blocks and water. Now, these models also focus on zones within a planet-forming disk known as the snow line. That's the region distant from the central star, which marks the area where water and other key molecules transition from a gas into a solid phase. It had long been thought that Earth, which contains only about 0.1% water by mass, must have formed inside the snow line. But Bergen says that type of model may be too limited. To expand the search for habitable planets, Bergen and colleagues suggest a new model, one that includes a soot line, a boundary closer to the system's star. Between this boundary and the star, organic compounds and solids sublimate out of the solid into a gas. Considering this region would also encompass rocky planets that may have more carbon than Earth, raises questions about what it means for habitability in these kinds of worlds. Bergen says just as Earth is poor in water, it's also carbon poor as well. He says when forming, Earth likely only received one carbon atom out of every 100 available in the protoplanetary disk. And he thinks that a soot line may explain why Earth has so little carbon. If Earth's building blocks formed inside the soot line, the temperature and solar radiation would be blasting the materials that would ultimately go on to form the young planet. And that would turn carbon-rich compounds into gas, limiting the carbon in the solids that would be supplied to the forming Earth. The author's modelling goes on to theorise about the formation of other exoplanets, those born between the soot line and the snow line. Of course, such a world does not appear to exist in our solar system. But the thing is, our solar system isn't representative of most known planetary systems around other stars. These other planetary systems all look completely different. Firstly, their planets are closer to their host stars, and they're also much larger, ranging in size from super-Earths to mini-Neptunes. So these are either big rocks or small gas giants, the most common type of planetary system. So, maybe with all these other systems out in the Milky Way galaxy, there exists a population of bodies that astronomers haven't recognized before, but one which would have a lot more carbon in their interiors. And that obviously leads one to question what the consequences of that would be. What does it mean for habitability? In their study, the authors modelled what happens when a silica-rich world with 0.1% to 1% carbon biomass and a variable water content forms in the soot-line region. They found that such a planet would develop a methane-rich atmosphere through a process called outgassing. In this circumstance, organic compounds in a silicate-rich planet produce a methane-rich atmosphere, and the presence of methane provides a fertile environment for the generation of hazes through interactions with stellar photons. And when you think about it, that's pretty analogous to the generation of hazes from methane which we see on Saturn's moon Titan. Bergen thinks planets born in this region, which exists in every planetary-forming dust disk, will release more volatile carbon from their mantles, and that could lead to the natural production of hazes. And importantly, these sorts of hazes have already been observed in the atmospheres of some exoplanets, and they therefore have the potential to change the calculus of what scientists consider habitable worlds. In fact, haze around a planet may well be an important signpost, telling astronomers that that planet has volatile carbon in its mantle. And the more carbon, the backbone of life as we know it, in the mantle, means the planet has a better chance of being considered habitable, or at the very least, it deserves a second look. This is SpaceTime. Still to come, NASA's first public UFO meeting. And later in the science report, new warnings that exposure to air pollution can increase the risk of heart problems. All that and more still to come on SpaceTime. NASA has held its first public meeting on unidentified anomalous phenomena, what we used to call UFOs. The 4-hour event covered a wide range of topics and questions and was live-streamed online. It follows last year's decision to have the space agency undertake an independent study of unidentified anomalous phenomena following the reaction stemming from the 2021 report issued by the Office of the Director of National Intelligence. The Pentagon was able to characterize 163 UAP events as being balloons or balloon-like entities, another 26 were identified as drones, and 6 others were either identified as birds, weather events, or airborne debris like plastic bags blowing in the wind. But the Office of the Director of National Intelligence concluded that it didn't have enough information to form an explanation for 143 other UAP reports that it had received since 2004. Mind you, that doesn't mean the Klingons have arrived and have begun terrorizing the village. Still, in October, NASA introduced a 16-member panel of experts from different scientific fields to head up their study. NASA's Associate Administrator for the Science Mission Directorate, Thomas Zabukin, says exploring unknown space in the atmosphere is at the very heart of what NASA does. But this public meeting wasn't a review or assessment of previous unidentified observations. Instead, it was designed to let NASA know where and what possible data could be collected in the future in order to help shed new light on the nature and origin of UAPs. Now, NASA defines UAPs as observations of events in the sky that cannot be identified as aircraft or other known natural phenomena from a scientific perspective. And if the Klingons have arrived, well, I for one welcome our new Kronos overlords and offer myself as a humble liaison between the Klingon Empire and the Terran homeworld. Kapla! And time now to take another brief look at some of the other stories making news in science this week with the Science Report. There are new warnings today that exposure to air pollution can increase your risk of heart problems. A report in the Canadian Medical Association Journal looked at hourly exposure to air pollution and the sudden onset of symptoms of arrhythmia, that is an irregular heartbeat, which could progress to more serious heart disease. Scientists used data from 2,025 hospitals in 322 Chinese cities, as well as air pollution concentrations from monitoring stations located close to those hospitals. They found that exposure to ambient air pollution was most strongly associated with atrial flutter and supraventricular tachycardia, followed by atrial fibrillation and premature beats. Additionally, among 6 pollutants, nitrogen dioxide had the strongest association with all 4 types of arrhythmias, and the greater the exposure, the stronger the association. While more research still needs to be done to find out how this occurs, the authors say the association is biologically plausible, and the results highlight the importance of further reducing your exposure to air pollution. A new study has confirmed that teens who vape using e-cigarettes with nicotine in them are far more likely to also be using cannabis and binge drinking alcohol. The findings, reported in the journal Substance Use and Misuse, are based on a survey of 50,000 teens in the United States about their drug use. It found that compared to those who didn't use any nicotine product, those who used nicotine vapes were 20 times more likely to also be using cannabis. And those who both smoked and vaped were 40 times more likely to use cannabis and also more likely to binge drink. The authors say that when tackling teen vaping, the likelihood that teens are also using other drugs at the same time needs to be factored in. The McMurdo Dry Valleys in Antarctica are inhospitable environments today. But a new study has found that they actually had a warm and wet climate more recently than was previously thought. Researchers studied the concentration of beryllium-10 in soil samples from 3 sites high above sea level, and they were able to identify when these valleys were last wet. The findings, reported in the journal Nature Geoscience, suggest the sites have been under a very dry polar climate since the late Miocene about 6 million years ago, and not the middle Miocene between 13.8 and 12.5 million years ago, as had been previously indicated. Microsoft's Build 23 conference has just concluded, with its new Copilot AI experience for Windows 11 and Edge being the starring attraction. With the details, we're joined by technology editor Alex Zaharov-Reut from TechAdvice.life.
This week is going to be the big WWDC 2023 Apple conference. Now, at the time that we're recording this podcast, it hasn't happened yet. But the big rumours are the headset's going to be launched, there'll be new Macs, and we should also hear a lot of things about AI, and we'll have all the details next week. But AI is going to be huge because at the Build 2023 conference from Microsoft, which happened in late May, AI was front and center for everything. They've got huge improvements for AI with apps for developers. I mean, it's a developer conference. And there's going to be a dev home, which will set up your computer and connect you to all the developer resources. Part of the big conference announcements for consumers was Windows Copilot. Now, this is going to be something that's in Windows 11 only. So it's going to give people a reason to upgrade to Windows 11 or to buy a new computer that comes with Windows 11 as standard or can be upgraded to Windows 11 at some point if you still need to use Windows 10 for some reason. And the Copilot, which will come in preview in June, will sit persistently on the right-hand side of your screen. If you want it to, there'll be an icon on the taskbar. And the whole idea is to revolutionize the way that you interact and work with your PC. You might remember Clippy from Office XP, which offered to help you when it saw you when you were writing a letter. And also Microsoft Cortana didn't really amount to much because it was a less impressive version of Apple's Siri, Google's Assistant, or Amazon's Alexa. And I mean, eventually it got discontinued. I mean, in the Halo games, where it was a all-powerful AI that could help you in multiple ways, I mean, that was never delivered by the Cortana that Windows had in Windows 10. But the Windows Copilot, it'll work with every app that you've got. It'll know things that you're surfing about on the web and offer you interesting information. You can pull documents into the Windows Copilot and ask it to summarize it for you or to rewrite it or to simplify it. You can drag in voice notes that you've created and it can transcribe those into text or translate it into another language altogether. If you ask it to play a playlist, it'll pop up a Spotify plugin and offer you chilled, pumping, playlist or some other sort of playlist based on your preferences. It will bring third-party plugins to you, first-party plugins. It will do these things without you having to open up apps, to remember to save on things, to close apps. It will be there, and the whole idea is you interact with it in a natural way as though it was a person, and it is making suggestions to you so you do not have to become a prompt engineer that knows the right questions to ask. Part of the problem with technology is that if you don't know the right things to ask, you're still using your iPhone like it was launched in 2007, as opposed to all the cool tricks that you can do that enable you to use your phone like it was launched in 2023. I'm often showing people all sorts of cool things that they just didn't know their phones could do. The thing is, though, if your device, your phone, your computer could sort of anticipate what you're doing, see what you're doing, and offer useful and interesting suggestions, then it really becomes a real help to you. Like the AI in all the sci-fi shows and movies where it's guiding you and helping you and holding your hand to some extent so that you can do a better job more effortlessly with less stress and complete the task faster. So look, we're yet to see if Microsoft can deliver on those promises. Microsoft is always really big on promises. But if it does work, if they get as seduced by it as they have been by ChatGPT or Bing AI Chat or even Bard, people are going to love it.
That's Alex Zaharov-Reutt from techadvice.life. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favorite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.